In this video, we're going to be talking about trigonometry and bearings. In surveying and navigation, directions are generally given in terms of bearings. A bearing measures the acute angle that a path or line of sight makes with a fixed north-south line, as shown in this figure below. For instance, the bearing south 35 degrees east in part A means 35 degrees east of south. So notice that we have our north-south line and that our measure here is 35 degrees to the east direction of the south line. So that is written as south 35 degrees east. In example B, we see that our line, or our bearing, is 80 degrees of north. 80 degrees west of north. And so we would write that one as north 80 degrees west. In our final example here, we see that our bearing is 45 degrees east of north, which is written north 45 degrees east. Let's do an example that involves a bearing. In this example, a ship leaves port at noon and heads due west at 20 knots, or 20 nautical miles per hour. At 2 p.m., the ship changes course to north 54 degrees west, as shown in this figure. So we want to find the ship's bearing and distance from the port of departure at 3 p.m. So let's first talk about the movement of the ship so we can kind of see it. So here's our port. Okay, there's our port. So we're going to go west at 20 knots. Now we left at noon and we didn't turn until 2 p.m., which means we did 20 nautical miles an hour for 2 hours, which is a distance of 40 nautical miles. Then the ship changed course and went west 45 degrees, right? So north 54 degrees west was where we're at now. And they did that for 1 hour because we see that it was at 3 p.m. that we're checking. So if that was 1 hour, that tells us that that distance was the 20 nautical miles. Because we're trying to find the ship's bearing and distance from the port at 3 p.m., it's all based about our port, really. So here we can see a few different triangles, and what would make it really easy is if we had just this one great big triangle that we could use right there. So what we're going to do is we are first going to find our small triangle right here, BCD. So we have side B, and we have side D, and we want to find our angle right here. We want to find that angle. Now what we know is that because this is a straight line, and this is, sorry about that, and because we know that this is a 90-degree angle, that means that together this and this must also be 90 degrees. And we already know that part of it is 54. So what we'll do to solve that is we will take, so we're trying to find the measure of angle DBC. So we're going to take that 90 and we're going to subtract the 54 from that. And that's going to give us a value of 36 degrees. And that's going to be helpful. So 36 degrees. I'm going to write that in a different color to make it a little bit easier to see. Now, using our 36 degrees, we can find our sides that we're missing. So using that 36 degrees, we can see that we have an opposite side and we have an adjacent side and we have the hypotenuse right here. All right, let's use a different color for that. And we have the hypotenuse. So to solve this, we're going to find the sine. So we're going to find the sine of that 36 degrees. I'm going to set that up as our opposite over our hypotenuse. To solve this, we'll go ahead and we'll multiply both sides by 20. And that's going to tell us that side B is going to be worth 20 times the sine of 36 degrees. So I'm going to go ahead and make that all one color real quick. Now we're going to leave it like that because we're not done. We now need to find our side D, that adjacent side. And so in order to find that, we're going to use the cosine. So if we take the cosine of that 36 degrees, then that is going to give us our adjacent side, which we don't know, that side D, and our hypotenuse, which is 20. So from there, just like before, we'll multiply 20 to both sides to get that to go away, and we'll be able to say that D is equal to 20 times the cosine of 36. Now I'm going to go ahead and I'm going to make that all one color so we can see it a little bit easier later. So now if we look at our triangle, we now know our adjacent side and we know our opposite side. And so we have enough information to find our angle right here, our angle theta. We have enough to find that. Let's go ahead and let's call that just angle A. We'll call that capital A, angle A. So if we have the opposite side, and we really have this whole bottom adjacent side now, because it's 40 plus whatever D is, right? 40 plus D, whatever our D is. So we can use this to use tangent to solve this. So we're going to go ahead and we're going to find the tangent of angle A, which is going to be our opposite side, which is B, over our adjacent side. Now our adjacent side is our 40 plus the D, plus our side D, right? So it's all of that. And we have those pieces, so now we just need to plug them in. We just need to plug them in. So let's go ahead and let's move this up a little bit. And we're going to plug in our values. So now we have that the tangent of A equals 20 times the sine of 36 divided by 40 plus 20 times the cosine of 36. So we're going to take this and plug all of that into our calculator, and we're going to go ahead and get a decimal, and we're going to round it to 3 decimal places. And so here we have it plugged into our calculator, and we're going to hit enter, and that's going to give us approximately 0.2092. So we're going to round that to 3 decimal places. And now we need to separate the tangent from the A. So we're going to multiply both sides by the inverse of tangent. So we're going to left multiply, which allows us to cancel the tangents out. So now we have the A is going to be approximately the inverse tangent of 0.209. And if we plug that into our calculator, that's going to tell us that A is going to be approximately 11.8 degrees. And so we can say that the measure of angle A is 11.8 degrees. So now we're ready to find our bearing. So we're using it from port, and so here we're going to see this is going to construct our, let's make it a little bit smaller, our north, south, east, west line. And what we're looking for is our ship's bearing. So we see that we're going to go from the 90 degrees of the north, so 90 degrees north, and we're going to take away that 118 degrees, it's our angle A, or excuse me, our 11.8 degrees, and that's going to tell us that we are at 72 78.2 degrees. So we can say that our bearing is north 78.2 degrees west. And so that is our first answer. We were also asked to find the distance. So we also need to find that C value right there. We need to find that distance. So in this case, we'll use our opposite side and our hypotenuse, so we'll use the sine. So our opposite, which is B, over our hypotenuse, which is C. And so we're going to go ahead and we're going to plug those in. And so we have 20 times the sine of 36 divided by C. And then a shortcut is when we have a C in the denominator like that, or variable, we can just switch that. So we're able to go that C is going to equal the sine of 11.8 times, or excuse me, it should be division because we're switching those spots. So we should have 20 times the sine of 36 divided by our sine of 11.8. And plugging that into our calculator is going to give us a 57.48. So we'll round that to 57.49 nautical miles. And that will be our distance. So there's an example of using trigonometry for bearings.